There is a question you have probably asked yourself but never said out loud. Am I actually intelligent, or do I just think I am? The internet is full of lists claiming to tell you. You like being alone. You stayed up late as a teenager. You have a dark sense of humor. Most of these lists are entertainment dressed as science, designed to make you feel good about whatever you already do. But there are actual, measured, replicated neurological markers that correlate with higher cognitive ability. Not personality quirks, not habits. Structural and functional differences in how the brain processes information. And some of them will surprise you because they do not look like what most people think intelligence looks like. This is what science actually says about how high-functioning brains work. And the first thing it says is that the most common sign of intelligence is one that most people mistake for a weakness. Sign 1. You worry more than average. Researcher Alexander Penney at MacEwan University in Canada found a significant positive correlation between verbal intelligence and worry. People who scored higher on measures of verbal and analytical reasoning also reported more frequent and more intense worry, including generalized anxiety and rumination. This seems counterintuitive. Worry feels like a failure of rational thinking, but the neuroscience suggests the opposite. Worry requires the brain to simulate future scenarios, evaluate potential threats, and model outcomes that have not yet occurred. This is computationally expensive. It demands high activity in the prefrontal cortex and the anterior cingulate cortex, the same regions responsible for complex reasoning and error detection. A brain that worries a lot is a brain that is running more simulations than average. It is processing more variables, modeling more outcomes, and detecting more potential problems. The worry is not a malfunction. It is the sound of a powerful processor running at high capacity. The cost is discomfort. The benefit is foresight. Researcher Jeremy Coplan at SUNY Downstate Medical Center found that among patients diagnosed with generalized anxiety disorder, those with higher IQ scores showed greater worry intensity. The anxiety and the intelligence were not separate traits. They were products of the same underlying neural architecture, a brain built to project further into the future than average. Sign 2. You talk to yourself. If you narrate your actions, argue with yourself internally, or verbalize problems out loud, you are using a cognitive tool that research consistently links to higher performance. Psychologist Gary Lupyan at the University of Wisconsin demonstrated that people who talk to themselves while searching for objects find them faster. The act of verbalizing activates language networks that enhance visual processing and working memory. You are not losing your mind. You are running a dual-channel system, processing information through both verbal and visual pathways simultaneously. Researcher Alain Morin at Mount Royal University studied inner speech and self-awareness and found that people with more active internal monologues scored higher on measures of self-reflection, metacognition, and cognitive flexibility. The inner voice is not noise. It is the brain's management layer, the executive monitoring system auditing its own processes in real time. Sign 3. You are easily distracted. This one contradicts everything productivity culture tells you, but the research is clear. Researcher Eric Schumacher at Georgia Institute of Technology found that people who report more mind-wandering in daily life score higher on measures of intellectual and creative capacity. Brain imaging confirmed that high-capacity minds have more efficient connectivity in the default mode network, the same system that activates during mind-wandering and between the default mode and executive control networks. The brain that wanders is not unfocused. It is running background processes. It is drawing connections between unrelated domains, testing ideas in the simulator, and exploring the problem space while the conscious mind is technically elsewhere. What feels like distraction is often the brain's creative engine operating below the surface. This connects to a phenomenon researchers call latent inhibition. Most brains learn to filter out stimuli that have been classified as irrelevant. This is efficient, but it limits the range of inputs that reach conscious processing. Researcher Shelley Carson at Harvard University found that highly creative individuals have lower latent inhibition, meaning they process more stimuli rather than fewer. Their brains are not failing to focus. They are taking in more of the world, which produces both the experience of distraction and the capacity for original thought. Sign 4. You doubt yourself more than others do. This is the Dunning-Kruger effect operating in reverse, and we covered it in detail in our video on imposter syndrome. The more you know, the more you see how much you do not know. Psychologists David Dunning and Justin Kruger at Cornell University demonstrated that people with low competence systematically overestimate their abilities, while people with high competence systematically underestimate them. The self-doubt is not insecurity. It is calibration. A more knowledgeable brain has a more accurate map of the territory, and a more accurate map reveals more blank spaces. The person who says, "I am sure," is often processing less information than the person who says, "I am not sure." Certainty, neurologically, is cheap. Doubt requires computational resources. Sign 5. You adapt your behavior to different contexts. If you speak differently to your boss than to your best friend, if you adjust your energy in a group depending on who is in the room, if you code switch between environments without conscious effort, you are demonstrating a capacity called cognitive flexibility. Researcher Naomi Friedman at the University of Colorado studied the genetic and neurological basis of executive functions and found that cognitive flexibility, the ability to shift between mental sets, is one of the strongest predictors of general intelligence. It requires the prefrontal cortex to rapidly disengage from one rule set, load another, and suppress interference from the previous context, all within milliseconds. This is not being fake. It is running multiple social operating systems and selecting the right one for each environment. Socially adaptable people are not performing. They are computing. And the processing power required to maintain that flexibility is substantial. Sign 6. You learn from mistakes faster than average. Researcher Jason Moser at Michigan State University studied the brain's response to errors using electroencephalography and found that people with higher cognitive ability show a larger neural signal immediately after making a mistake. The signal, called error-related negativity, originates in the anterior cingulate cortex and reflects the brain's error monitoring system. A brain that generates a stronger error signal is a brain that is paying more attention to its own mistakes. It is not more prone to failure. It is more responsive to failure, which means it corrects faster, adapts sooner, and is less likely to repeat the same error. The difference between someone who learns from a mistake and someone who repeats it is not motivation. It is the strength of the signal their error detection system produces. Sign 7. You find it hard to fall asleep. Researcher Satoshi Kanazawa at the London School of Economics analyzed data from a large longitudinal study and found that individuals with higher childhood IQ were significantly more likely to be night owls as adults. The correlation was not explained by profession, lifestyle, or social factors. It appeared to reflect a genuine biological preference for later sleep timing. The proposed mechanism is evolutionary novelty. For most of human history, nighttime activity was limited. The brain's default setting is to sleep when it is dark. Individuals with higher cognitive ability are more likely to override this default, to find the quiet hours of the night productive for the kind of extended, uninterrupted thinking that the daytime environment makes difficult. The same prefrontal cortex capacity that enables complex reasoning also enables the conscious override of circadian impulses. This connects directly to our video on overthinking at night. The brain that cannot sleep is often the brain that is still processing. The default mode network in high-capacity individuals remains active longer, running the simulations, reviewing the day, projecting into the future. The difficulty falling asleep is the cost of a system that does not shut down easily, because it has more to process. None of these signs look like what the culture tells you intelligence should look like. Intelligence, in the popular imagination, is confidence, focus, calm certainty, and effortless achievement. The neuroscience tells a different story. High-functioning brains worry more, wander more, doubt more, and sleep less. They process more inputs, run more simulations, and generate stronger error signals. They are noisier, more restless, and harder to live in. The experience of being in a high-capacity brain does not feel like clarity. It feels like too many tabs open at once. And that feeling, that too muchness, that sense of a system running at the edge of its capacity, is not a sign that something is wrong. It is the sound of a machine that was built for more than the average load. You have probably asked yourself whether you are actually intelligent. The answer, if the science is any guide, may be hiding in the parts of yourself you thought were the problem. The worry, the wandering, the doubt, the restless nights. They were never the signs of a broken brain. They were the signs of one that simply has more to do. And there is one more pattern that the research reveals, and it may be the most important one of all. Researcher Sophie von Stum at the London School of Economics conducted a meta-analysis of cognitive ability and personality traits and found that the single personality trait most consistently associated with intellectual achievement was not conscientiousness. It was not openness to experience. It was what she called intellectual curiosity, a persistent, internally driven need to understand how things work. Curiosity does not feel like intelligence from the inside. It feels like dissatisfaction, like something is incomplete, like the answer you were given was not enough. But neurologically, curiosity activates the dopaminergic reward system in a specific way, not in response to receiving information, but in response to detecting a gap in existing knowledge. The brain rewards you not for knowing, but for noticing that you do not know. And the stronger that reward signal, the more relentlessly you pursue the answer. Researcher Matthias Gruber at UC Davis used brain imaging to study curiosity states and found that when curiosity is activated, the hippocampus, the brain's memory consolidation center, becomes significantly more receptive. People in a state of curiosity learn faster and retain more, not just about the topic they are curious about, but about unrelated information encountered during the same period. Curiosity does not just motivate learning. It physically opens the brain's capacity to absorb. If you clicked on this video because you were curious, not because you needed validation, but because you genuinely wanted to know what the science says, that impulse itself may be the most reliable signal of all. Not every intelligent person worries. Not every intelligent person doubts themselves. Not every intelligent person stays up late. But nearly every intelligent person shares one thing. They could not stop asking why. And the brain that cannot stop asking is the brain that never stops building. That restless, noisy, too many tabs machine you are carrying around is not broken. It is doing exactly what it was built for. And the fact that you made it to the end of this video, that you are still here, still processing, still curious, tells you more about your brain than any list ever could.